The screen is visible.
Yes, it's visible.
Okay, so we can start. So I am Yash, and we are here about the introduction to GitHub Actions. So we can just start with GitHub. So for the outline, what we will learn today is what are the GitHub Actions. Then we will move on to CI and CD. Then we will move on to how to use those actions, and then we will see some examples, and then we will use the secrets for GitHub Actions, and then we will have some exercises that you can do yourself, and then maybe you can share them with your peers or to get some feedback. So first of all, what is GitHub? So GitHub, as most of us know, is a platform, like it is a code sharing and collaboration platform where you can create repositories. Repositories are just like folders where you can save your code, and then there can be branches and there can be deployments and everything. So GitHub is a centralized platform that provides us with all these functionalities. But the thing is, this software development is much more than just storing code and like declaring functions and executing these code. So what GitHub Actions allow us is it allows us automation. So we can basically create a pipeline of tasks. So, but we can basically create a pipeline of tasks that is known as CI/CD integration. So this CI is a practice where developers integrate code into a shared repository. So continuous integration can be thought of as like automated tasks where you are just pushing your code and then your code is being tested, it is being linted to make sure that the code is of pretty good quality and it's not of inferior quality. Then continuous deployment is a strategy. Let's say you have two servers, right? So for these servers, when you push the code, they will automatically build the image and deploy them to the server. This is what we call continuous deployment. So for continuous deployment, we typically use things like Kubernetes and Docker. And then we have different environments. So we can typically build different images for different environments using GitHub Actions. Now, how to use GitHub Actions? So to use GitHub Actions, we can actually start with the repository. So you guys can follow along if you want. So the screen is visible, right?
Yes, it's visible.
So we can maybe create a new repository here. So let's name this repository as something like actions and then sample. So with this action sample, make sure to set the repository as public if you want people to give feedback. And if you want it to be private, then you can have it private. But private repositories have limited GitHub Actions. Like you can use GitHub Actions in a limited scope, and there's always costs associated with it. So now we can create a repository. So this is a blank repository. To create a GitHub action, what we need to do is we can create a file. So all of these actions actually are stored in a folder which is known as .github. And then that .github folder has a workflows folder. These workflows folder have all the scores. So we can create a sample action here. And let's name it maybe demo.yml. So YML is a YAML file format. YAML file format is normally used for things like deployment and things like actions. So here we go. And the biggest thing with this is if you are using GitHub Actions, the biggest benefit of GitHub Actions is the GitHub Actions marketplace. So what you can find here is you can find an action here for basically anything. Let's say you want to deploy to Docker, or let's say you want linting. We will just go here and find the action that you want, maybe like something like Python linter, and then you would get these workflows. Now the thing is, you can include these workflows in your own code. So every of these marketplace actions can actually be used in your code. And like I will show you later how to use them. So is this thing clear, like what workflows are, what GitHub actions are? If they are not clear, just raise your hand. If the concept of GitHub actions and workflows is not clear, please raise your hand. Okay, then I guess we can move on. So for every action, what we have is we have a name. So you can define any name for an action. Let's say this is a base action. Let's call it base action. And then we also have to define the run name. The run name is what it runs as. So let's say what I need to do is, let's say print to console is what our, sorry, print to console, no, that would be wrong. So we can maybe name it sample action. And that is what it would be. And then now the thing is, we can use this on thing. What on does is, it tells us when do we have to run this action. So let's say you want this action to be run whenever someone pushes to the repository, or you want this action to be run whenever someone forks from the repository. So in that case, we can use it. So let's say we want to push. So this action will now run whenever someone pushes anything. Now this is our action workflow. So this workflow is an action, and each of that is known as a job. So if we go to jobs, and then this is how we define jobs. What a job is set of like actions where, like, let's say you want to print something, so that would be under job. You want to link something, that would be under job. And we can name this job as explore action. Better we can just use code for it. Just a second. So let's name this action as explore action. And then we have to define where this job actually runs. So we can say run on. You can basically use a set of operating system for this. Like you can find a list here, GitHub action, run on, and then workflow syntax. Like you can use a variety of operating systems. You can use Ubuntu, and then you can also deploy it on your own infrastructure and then provide a runner here on runsome. So let's say our action runs on Ubuntu and the latest version. So we will just write Ubuntu latest here. Then we will have to define the steps that we have to execute in. So it's a sample one. We can basically print to the console. Echo, as most of you might know, is like we use it in Bash to print something. Bash is what the default language and the shell for Ubuntu is. So let's say this job was, no, something was pushed. So this is our runner, and then we can save it. So is this clear? Any doubts still here? Any doubts still here? Yeah, I guess we can move on. And so now when I save it, so this is our demo. So what it will basically do is, this action name is base action, and when it runs, it will run with the name of sample action. And it will run on push, and it will perform several jobs. But here we have only one job. Like you can define multiple jobs here in this section under jobs. So what job is, like we have only one job, and that is known as explore action. It runs on Ubuntu, the latest version. And what it does is, it will just print something was pushed to the console that we see. As usual, we can commit the changes. And let's say we create demo.yml, and then we commit the changes. So now, if you go to
Yes. Can you be little bit slow?
okay. So now this area here, it shows what your actions are doing. If it is yellow, then it means that your action is still running and it's pending. And if it is green, then it means that your action has successfully been completed. If it is like red cross, the red color cross, then it means that your action has failed. So if we go to detail, you can basically navigate to that actions tab over here. And here you can find all the actions that you have. So if you go to the actions tab, we currently have one action. And here it is. So you can go to the sample action and it will show that what jobs have run. So if you go here and basically, yeah, so it will show for the setup job, it will show like the environment that has been created. Like as you can see here, operating system is what we actually defined there. And then we have this GitHub token. And this is basically what permissions this action has for us for our repository. And then we are basically echoing something was pushed. So like as we mentioned in that workflow, it actually printed the thing like something was pushed because we pushed something to the main. Now the thing is, we can basically do many things with these workflows. Now, like let me show you one thing. We can create another workflow. Like we have a variety of syntax in this workflow. So for things, let's call it script demo. No, not actually. Let's call it demo. This section is what we know as demo, and let's name it demo v2. And for this, let's save the run name as. Now for this, we can actually use dollar and then brackets. Now what we will do is we will try to like when it runs, we can actually try to use the runner's name. Like let's say my username is yashkc2025, right? So if I put something and the code runs, like if I put something and this action runs, then we can actually like get the name of the person who has pushed the code and triggered this action so that we can later filter out. So let's do it here. I can do GitHub dot actor and then is like has pushed something, has pushed. We can use this. And as usual, we can use this on push as well. And then we have these jobs. So let's call it, this time we can call the job as demo. And then maybe call it like extension because this is the second demo that we have. And as usual, we can define the run on variable that we have. That would just show what operating system are
Just a
actions and
minute.
so on.
Yes. We have one raised hand.
Okay.
Yeah. And
So,
yeah, can check in
yeah, let me
chats
check.
or
Okay. Sorry. So just a second. Now, voice let me access it. Okay. Yeah, recording will be provided. Don't worry. Okay. So what the goal behind GitHub Actions is? So the goal behind GitHub Actions is just think it like this. So let's say you have a repository, right? You work in an organization where multiple people are contributing to a repository. And then you have a tester who is testing the code and there's someone who is deploying the code to the server. So what you can do with GitHub Actions is you can write your test, right? And then you can integrate those tests in this GitHub Actions and GitHub Workflows files. And whenever someone, yeah, I will just give a recap. Just wait a second. And then when someone pushes the code, what will happen is that action will run and it will show you whether your code is whether your code is of good quality, whether it has any errors, so that before you merge to the main branch, like the primary branch that is your code, before you merge to that branch, all the errors are code and like your main branch is clean. The first thing, this is what GitHub Actions for testing can be done. And for the second thing, you can use GitHub Actions for deployment. Let's say you have a repository with code, and what you have to do is whenever someone merges to the main branch, you want to deploy that instantly to the backend server. So what you will do is you will set up a deployment on this GitHub action. Let's say, let's say you are using Docker. So what you will do is you will just write a Docker script, like Docker file, that would take the contents of this repository and then build a Docker image. Then you can push it to something like Azure Container Registry or ECR, Elastic Container Registry, from where it can be deployed to Kubernetes. So this way you can automate the process. Like if you do this process by yourself, it would this deployment process by yourself, it would typically take you over like something like 40 to 50 minutes. But if you set it in the GitHub Actions, you can basically get it done sooner, and then like the manual labor is reduced. Everything is automated. You can easily do things. So, hey, Ritik Roshan, is this clear? Okay, so for the one that was saying, okay, so for a short recap, so yeah, so we are here talking about GitHub Actions. Are you sharing it? No, no, I'm just like currently at the Teams only. I'm not sharing right now. Just wait. So what this GitHub Actions is, it's an automatic deployment platform. And like, as I explained before, we can use it to do a variety of tasks. So any other question? Any other questions? Okay, so I guess we can move. So, yeah, so again, we will just, as we saw before here, we can actually log the name of the person or the username who has triggered the initial workflow run. So this GitHub.actor can actually help you identify who has targeted this particular action. And then we can again define runs on Ubuntu and then latest. Then this time, rather than one step, we can do many steps. So yeah, so I was talking about the testing thing. So to test a repositories, like to test some code, what you need to do first is you need to define the name for your step. So let's say check out repo code or checkout code. What this checkout code is, you can use users. In the starting of this session, I actually showed you guys GitHub Action Marketplace. You remember that? So we can just go over to the GitHub Action Marketplace and I can show you this. Like as I said before, you can go to the GitHub Action Marketplace and here you can find the things that you can actually integrate in your action. So one thing that we are going to integrate now is this. We are going to use action / checkout and like v4. So what it is a what this action will do is it will just copy your repo code or your branch code your thing to the runner where it will be executed or it will be tested or it will be built or it will be deployed. Like anything that you want to do there, this action checkout will just do. Like it will just copy over the code from your repo. Then once this is done, we can also try to we can also try to log the name of the repo. So to log the name of the repo, we can again use this echo command. This echo will just print. And this time what we can do is we can again use dollar and then brackets. This dollar brackets is like it's a variable kind of thing. Like if you want to concatenate this particular property into the string, you can use this. And again, we will use GitHub dot. And this time, what we are going to use is repository. This will give you the name of the repository that we are currently on. And if we have files in the repository, you can technically console the files also. So let's also try to list the files that we have in this repo this time. So to do that, let's maybe define a new name. So this will be list files. And then we can do run. And then we can do this. Like this is the Linux command ls. ls is basically used to list the directory, like whatever is in the directory or that's folder or whatever you call it, everything will be listed. So what we are providing is, we are just providing this repo parts that is there in the code. So we will do github.work workspace. And like that would be it. It should work. Yeah, my bad. It's run zone, not run on, my bad. And then nothing was not expected. So I guess we do have some error here. Like we need to check a second. Yeah, I forgot something. My bad. So whenever you're using names or run, you have to actually use this as well. And without this, it won't work. Like give two spaces here and then push this users to underneath and then this run here. And then again, you are, because you are naming a name, so you can just do it like this. And now our actions is fine. So we can go to this and let's call this demo v2.yml. Remember, yml is our YAML file format used for this workflow thing. So as soon as you type YAML, just see on the right side of my screen. As soon as you type YAML, you will see a list of actions here that you can actually integrate. And you can also check out the documentation. Like it will provide you with the cron jobs. Like if you want to run your action on a certain time, like this is 02. So this is a cron format that we have. So what it will do is it will run every day of the week from Monday to Friday at 2 UTC. So you can actually find a pretty good documentation, the official documentation that we have for GitHub Actions here. And yeah, this is the list of the virtual machines that are available. You can run your code on Ubuntu, Windows, or even Mac. And you can also provide your custom runner for it. Yeah, so you can save this. So the thing is, like whenever you are pushing something to the main branch, the thing is that you have to create a new branch for it, and then you have to open a pull request. So let's do it the correct way. Let's first create a sect branch. So let's name this branch as demo v2 and then propose the changes. Yeah, so like I've created a new branch here as we should always do is, and then we can navigate to our demo v2 and then we can compare and pull request. So you can actually see the files that you have changed here under the pull request, and then you can create a pull request. And then like if you are the only person that is reviewing this repository, you can actually merge your pull request without anything. And yeah, so this GitHub action that we are talking about, so it will actually show up here. You see this 2 successful checks now? It will show up here, whatever you have done with those actions. If you click on show all actions, it will show. The first action that we defined previously, that was just echoing. So it is shown here in the detail. You can just see it is for pull request run. So this is how it works. Whenever you are trying to merge something, like you are pushing something, that action would run and it will show what is wrong, what is right. Like if you have some linting errors or you have some other errors, you can check the second one as well. And now we are merging it. So let's merge it. So it's now in the main branch. You can go over to the main branch, click on the action. So this is like working like, so now this is the thing. In our actions, we actually use this GitHub.actor one. So what it did is, it actually showed who has triggered this action. So my username has been logged in. So now when I go to the actions, I can actually see which action has failed. And okay, so this action has failed. So I can just see it has failed because of me. And then this way we can actually identify the action. Then we go to demo extension. This is the name that we defined initially, if you remember. And then again, we have this setup job. So here again, we have this like action repository. See, this is what I was talking about like integrating other actions in your code. Now, checkout code is this checkout code step was when we actually clone this repository onto our runner. The runner is the machine that actually tests and like runs our code. This action, like whatever machine that runs this action, is called our runner. And this is the run echo. So we defined here, right? So what we did is we defined that it should actually echo our github.repository, like the repository name that we have. So it actually did it. Action sample, like this is what my repository name is. So it worked. And for the next one, we also try to list the files. So currently the files that are in our home directory, like our directory is this, like we only have this. There's not much currently. It won't list .github workflows. Like if we have some files in here, it would show. But because our repository is currently empty and it has nothing, it won't show. This github.workflows folder, it won't appear in that ls because it is a hidden folder. It is dot. Now, yeah, so this is recap. So
we
yeah,
have some
if you guys,
doubts in
yeah, definitely. So yeah, just a second. Like give me a minute for me. So uh, yeah, so can we also use JSON or YAML is the only one? I guess YAML is the only one. Like I've never tried with the JSON one, but I don't think that it's not might be possible, but I don't know about it. Like, is this recorded? Yeah, definitely it's recorded, man. And what is the language used here? So it is YAML. YAML, if you search here, so it's a human readable data serialization language. Like you can basically list your task here. So it's a simple, it's not a programming language. It's just a language that you list your task in. So it's not a programming language. And then the thing is, where is Ubuntu latest machine means in which machine YAML is run and ls run. So this Ubuntu latest machine is actually the machine that GitHub manages for us and provides us for free. Like if you are running for a public repository, you can get this action run for free. So this Ubuntu latest machine. So to check this GitHub Actions runner, what we have is we have two kind of runner. The one is GitHub hosted runner. The another one is self-hosted runner. So currently we are using this GitHub hosted runner. So what is happening is, sorry guys. So currently what is happening is we are using the runner that has been provided by GitHub for us. If you want, you can actually use your self-hosted runner. And let me show you. Yeah, so for the self-hosted runner, this is something that you manage on your behalf. And like you have this GitHub script installed on that hardware that will just provide you a way to execute this function from here, right here from GitHub on your own machine. So currently this is from where to learn YAML. The YAML is not something that you need to learn as such. It's basically a data serialization. Like you have basic things. If you want to learn something like you can check up the GitHub Actions official like documentation. That documentation teaches you pretty much everything that you need from YAML. Like I'm just pasting the documentation link here. They do have a quick start guide. Take a look at it whenever you are free. Just check this one. Like any other questions that you have? What if there are merge conflicts? Merge conflicts in the sense merge conflicts for GitHub Actions? Like I'm not getting it. We want merge conflicts for GitHub Action?
Yeah, so right now when we push the code, it gave us the option like merge the request. So let's say there are two developers. One has already pushed the code, and second one is pushing. Then there can be conflicts, right?
Yeah, definitely.
Okay, then that we have to resolve locally, or is there any option in the GitHub Actions?
See, let's say let's take a realistic scenario. Let's say you are working on a file. Let's say that file is your typical Ludo game. Okay. So you have written an algorithm. The other person has written an algorithm. You have modified the same file and you have actually copied from the same, like you have initially, both of you guys initially had the same file state. Like the file was same, but then both of you guys modified that file differently. And when you are merging it, you will get merge conflicts. So you will always have to resolve these conflicts yourself. Like how would the GitHub action know like which part to keep and which part not to keep in that file? So merge conflict is something that you have to resolve on your own manual. There's no GitHub action for automatic resolution. Like it might be possible by AI, or maybe tomorrow, today, something pops up that solves something like this with AI merge conflict. But as of now, I don't think GitHub Actions can do this.
Okay. No.
Like, can I continue? Okay. So the next thing. Yeah. So for the events where we define the push, we can actually define multiple things here. We have this fork. So what will happen is whenever someone forks your repository or forks your branch, this will run, and then release. So what release is? Let me show you a release. This is create a new release. So what will happen is if you go here and you create a release like something like sample release, and then you publish the release. So as soon as this release is published, release is basically one of your branches that you want to make. Like let's say you are working on a feature for your application and it has been completed. So you just want a new version for it. So you will just release that particular branch and you can later on create APK or exe or DMG file for it, or maybe Docker image. So that is what your release is. And then this schedule. So basically we were talking about the cron job over here. Like let's start to GitHub doc. And like there was this cron job. We have a cron job thing, right? It has a format. This is basically a format like where you define how your schedules will run. So this schedule thing will happen is you want to run your action maybe like once a day to clean up something in your code or to check whether everything is working fine. So these are the events. Or when someone deletes a reference or deletes some part of your code, this will run. Now moving on to the properties, this GitHub.actor properties, something like we tested before. It will basically show who has tested or who has pushed or who has triggered this action. GitHub.event name is what will show you what has happened. And repository is basically like it will show you repository name, and workspace is basically it will give you the contents. Then we have this job.status. So if you go here and go to actions, by the way, any of you like if you want, you can just browse this repository right now if you want. So I'm just dropping the link here. You see here, like we have all these green ticks. So this, like all of our checks have passed till now. But what if it failed? So what we can do is we can take some action and then check its status and modify another action. Like we can write an action such that it checks the state of or status of another action and performs some task. So in that case, we can use this job.status. Then we have the secrets. What the secrets does is, this secret, like in our code, we typically need to use API keys and API keys or database passwords, database credentials, things that are sensitive. So if that thing is in your code, so anyone who has access to the code can view that. So this way your API key or database password might be leaked. Let's say I'm writing a runner here, or no, I'm just writing a file here that says maybe it has our API key stored. So it has our API key, and that is unsafe. So currently it is unsafely stored here, and anyone can have access to it. But if we want to secure them, we can go over to the settings, and then from the settings, we can go to the code secrets, and here action. Now we can create a secret here, like new repository secret. I can go and maybe I can do this. I just give something. Yeah, so we can maybe define it like, let's say I have an API secret for my Azure database. So I can just type the secret here, like something like and then I can save this. Then I can go over to my runner, the code where my runner is. And then what I can do is, just a second, I can do secrets. Okay, leave it. Use secret. And I can just pass it to some script or something. So the thing here is, like, you can use it something like this. So it will be $, and then again we have these brackets, and then secrets dot my API secret, or the name that you define for your API, or the name that you define for your secret. So you can use it here. Now the thing here is, so technically what someone can do is, someone can create a new action, and to get the secret, what they can do is they can use this echo command. So what they can do is they can use this echo. So in this case, what should happen? So most of us will think that it will just log to the console, right? So what should happen? Will it just print to the console? Like, any ideas for any of you? Yeah, so the thing is, it won't even be console. Like, it would skip it altogether and just show star, star, star. Like, it will just show 3 to 4 stars like this, like I put in the chat, and it won't show anything at all. So this way your secret would be protected. And then you can pass it to a script or something right from here. From the run command, you can pass it to some script, and then the script can securely use it. Like, is this clear? This is clear, right? Okay, so yeah, this is a sample code for secrets. But this echo command won't work here. Like, the echo command that we have in the bottom will just print a star, star. I just created this example to show you guys like how we can try to log the secret, but it won't log at all. So this is basically worthless. You cannot log a secret. Now what we have now is, yeah, we have this exercise, simple exercise here that we can do right now. So we can create a Python linter. Like, are you guys fine with Python? Python is fine, right? Yeah, okay. So yeah, I took Python because Python is it's an easy language. Everyone of us know it. So I can go to action sample, and I can make a new branch here. Sorry for that. Hit code and then create a file. Okay, so or we can first create a linter. So we can go to GitHub Workflows and create a new file. This time, let's name it something like linter. What linter does is a linter will just check your code and point out the lines or the places where your code can be improved to follow certain guidelines. We use these linters in our companies and organizations to maintain certain code structure so that the code is readable by everyone who works in that organization because they follow a same pattern. So we can use this linter.yml. Again, we will use this YAML format and let's name it lint code base. And let's run it on push. Again, we have these jobs. And yeah, so we can use the build command. And in lint code base, again, we need to define, or maybe we don't need to define. Like, it's up to you. I like to define it multiple times, so it's pretty clear. When you have run stone, yeah, we are again going to run it on Ubuntu. Yeah, it's the fastest machine available. And then we have a step. So to lint our code, we definitely need to check it out onto our runner. So we will do checkout code. You can basically, yeah, you can do it to any name. Like you can say something like copying files. It's just for your sake, like whatever you want. I like checkout code, so I'm using it. And then you have this users actions checkout at V3. Previously, like if you notice, we were using V4, right? We can use any of them. It doesn't matter that much. So like we are using V3 here. It won't matter. You can do anything. And then we have this name. So yeah, so we have to go here. Yeah, let's find some linter for our Python, right? So we type Python linter. So let's use this first one. Now they have defined how you should use it. So they have defined it like this. You can actually use this in your code like this. So I'm just copying it up. Python linter, yeah, I can copy it up and use this. Then I can go back to my code and then use the desktop and move it. Tap. Also, you need to align the code. It won't run without indentation, like it will throw random errors. And so this is basically for checking our Python code, whether the code is like whether the code follows a pattern or a code is like broken or something. We'll just commit it. Yeah, we'll create a new branch for it. So Python linter setup would work. And then we'll propose the changes. Yeah, you can always view the files that you have changed here. And you can create a pull request. Yeah, see the checks we actually defined are being run here. And this lint code base is also running, even though we don't have any Python code right now. So it has failed. Let's see why it has failed. So what it has said is there are no Python projects. Like it's currently empty, so it cannot do anything. That is why it has just failed. So let's try to create a sample Python file for it. So the thing is, I do have a file for it, like a file that is quite buggy, and we can use it to test this linter, whether everything is working or not. So we can name it test.py. And just a second. Okay, so yeah. Let's write a simple file that is buggy according to Python. Call it 1, 2, 3, 4. So this is a simple Python program. For in range len of my list, right? And then if my list I is greater than 3, I want to print element at index and then is greater than 3. Yeah. And then with that format we can use, and then we can use I and close it. Else print, okay, just we can do it here. And now see it. As like you guys know that Python does not work without indentation. You have to provide proper indentation. So let's say I'm not providing indentation here. Let's say this is out of the loop, or it's at the same place that if is. So now if I try to commit this file, because this file actually has an error, indentation error here. I have not provided the current indentation. So it is an error. Now if I try to commit it and let's say test file Python, and then I'm creating a new branch for it again, and I'm proposing it. Yeah, so let's open a pull request. Okay, so I guess we have not merged that one yet. My bad. Yeah, we have to merge this one first. Python into it. Yeah, and refresh this page. Okay, so we have a little issue here because we did not merge that file there. Like the test file was not properly merged. This branch does not have that thing. So we need to create, like, let me copy over that to a new branch. Just a second. Yeah, so now these 3 tests will run. So we have this lint code base, let it run. You can go to the details, and then it is currently building our runner, the container, to run this code. And then it is now checking out the code. It has just copied the code. Yeah, so it has failed. If you remember, if we go back to our code, that we have here, action sample, and then over to this pull request. So what we have here is we actually have an indentation error in this file. Yeah, right here, like right at the line 5, we don't have proper indentation. As a result, we have got the error here. Test 5 print element at index. So what it says is expected an indent block, like how the typical, like when you run this code locally on your computer, this will be shown. So this way, if I go to the pull request now, it actually shows that some checks were not successful. And the thing is, the merge pattern is actually turned gray. Like it was initially green. Like when everything was passing, it was green and now it is gray. So this way you can actually protect your main branches. You can actually protect your main branch from buggy code. Like you can set up things like linting and then testing. We have this framework, a really nice framework for Python. That is the PyTest. You can basically use this PyTest framework in that GitHub action to test your file, and it will throw up errors if your API routes and things are not correct. Similarly, you can actually use ESLint for JavaScript. This will find the problems and also fix them. So you can use ESLint, and for Python, you can use PyTest. So you can use things like these in your, like these small things in your GitHub actions so that your code is of better quality. And these manual things, like if we are checking this code manually, it will take a long time. If we are testing this code manually and running it every time on our own, like it will just take a long time. So we can just use these GitHub actions for these things. So like, yeah, the same goes for the stake home exercise. This is what we actually did right now. So yeah, we can take any questions that you guys have. Yeah, we can just take the questions. Any questions? Okay. So I guess no one has any questions. Yeah, so this was all from my side right now. We do have an feedback form for this one. So please take out your time to fill this feedback form. It will really help us. And yeah, this recording that you guys are seeing, it will be uploaded. Like I will upload and share the link to all of you. And also this will be available in your Teams. So for those that are using a Teams account, this will be available. And for those who are not using a Teams account, I will just upload it somewhere, upload it to YouTube on our college society's channel, and then I will just share the link to all of the participants that were here in this meeting. So, so yeah, thanks, man. Yeah. So if you guys, any of you have any issues or any problem, you can just you can just reach out to me on my email. This is my email, yash.kumar12@ambassadors.com. Or you can just go to my website and find me there also. You can find all the things. So thanks, man. Yeah, thanks everyone.
Thank you so much, Yash, for a wonderful session. Thank you
Yeah.
all for participating.
Yeah, thank you.
Please fill the feedback form.
So shall we end? Pramod?
Can I stop recording? And
Yeah, okay.